Hello there. I got this table from the Integrated 1 book and thought that it might be interesting to look at when talking about independent events, how to test for them, and the multiplication rule. So, are these events independent? There's a couple different ways of going about this. I'm going to use the sample space test. And that's the idea that if I shrink the sample space down, so probability of A given B, is that the same as if I hadn't at all? So for this one, let's say the event A will be survived. So what's the likelihood that you survived? Go look at all the survivors, so that's going to be 492 over 1324. And now I'm going to shrink the sample space and say, well, what's the likelihood that I survived if I was a guy? So now I'm no longer looking at the women and children, I'm only looking at the men, and my likelihood, so there are 138 men who survived out of 816 men all in all. And now I have to look at and compare these two numbers here. So the fractions are really different. I want to convert these into decimals. This top one as a percent is about 37%, 37.16 if I'm going to go to two decimal places, and the next one dropped considerably is only 17%, or 16.91 if I go to two decimal places. So, likelihood in the general population of being a survivor in this ship was 37%, but then when I looked at just the men, only 17% of the men survived. Not so good if you're a guy. So are these events independent? No. And the backup for it is this work over here. And I always want to see the numbers to support this. So this was the idea of shrinking the sample space. I could have done it the other way around. I could have also looked at probability of being a man, which would be 816 over this, and probability of being a man given that I was a survivor. And that would also lead to a similar conclusion that those probabilities are not the same. Okay, so because these events are not independent, I cannot use our normal multiplication rule. And normally I could just multiply probability of A times the probability of B, so probability of being a man, 816 over 1324, that's probability of being a survivor, 492 over 1324, and get that percentage. But that will not work out this time because these events are not independent of one another. So I need to modify the multiplication rule. And we do that by chaining together both of these events. So if I'm looking for the probability that it's a woman and child, or woman or a child, and they're a survivor, that has to be, two things need to happen. They need to be a woman or a child, and they need to be a survivor. So I'm first going to account for the woman or child part, so that's the probability of being a woman or child, and that is, how many women and children do we have all in all here? 508 over 1324. And now I'm going to multiply by the probability that it's a survivor, given that I've shrunken the sample space, so given that it's a woman or child. So up here in the table region, I know that I'm only dealing with this region now. So there are only 508 in this sample space, and to be a survivor, I have a woman who's a woman or child. I have a 354 chance. And then I can multiply through, and you'll notice that the 508s cancel in this, so this is going to be 354 over 1324, and you will see that that is that number exactly there. All right, character and scholarship for life.